Hi guys, welcome back. Here is part 2 of our 4.1 videos. We're going to go ahead and look at the properties now of our quadratic function. And I just want to make sure that you notice something up here in the way I've notated it. I'm not using this f of x, and we're going to slowly kind of start moving to f of x notation because we're going to start doing a lot of function work this semester, okay? And especially when it comes to transformations and the new functions we're going to encounter, like our exponentials, logarithms, trigonometric ones. More on that later in the semester. But when we get to those, we're definitely going to want to make sure we know how to use this function notation, okay? So let's go ahead and we're going to draw some generic parabolas. Hopefully they're not too hideous. Yours will probably look gorgeous, but mine are going to look pretty nasty. Okay, so I'm just going to do this. And then I'm going to do this. Okay, and the reason why I'm doing this is I'm just drawing some generic parabolas. Okay, these are some random quadratic function graphs because we want to talk about the properties really quick. Okay, so our first property is that the graph opens up if, and here what we're going to say is if a is somehow related to 0, and it opens down if a is somehow related to 0. Okay, maybe pause this video really quick. Notice that the a that I'm talking about is this a right here, the leading coefficient of our quadratic function. What's the relationship between a and 0 if it opens up and if it opens down? Maybe pause the video and think about it. Okay, hopefully you said, or maybe got close to thinking that a is bigger than 0 if it opens up, and a is less than 0 if it opens down, aka a is positive or a is negative. Okay, so in this graph, our a is bigger than 0, and in this graph, our a is less than 0, all based on the way that it's opening up or down. Okay, so I'm gonna have to actually scroll down a little bit. Okay, our axis of symmetry is going to be x equals negative b over 2a. I'm going to rewrite that so you can see the negative better. Negative b over 2a. All right, and again, that's the b and the a from our quadratic standard form. Okay, the b is our middle coefficient, the coefficient on the x, and the a is our leading coefficient. Okay, so what this says is that if I have a quadratic function that I haven't graphed yet, so I don't really see the axis of symmetry yet, I can calculate it by taking b, dividing it by 2 times a, and then sticking a negative in front. Okay, now remember the axis of symmetry crosses through the vertex, so we can guess that the x-coordinate is going to be negative b over 2a because it has to match up with the axis of symmetry. Well, now how do I get the y value? Well, I get that by plugging negative b over 2a, the x value, into my function. Okay, that notation's a little weird, but that just means take the x value, plug it into our function. Take the x value, plug it into our function. Okay, we'll see what that means in a little bit. So bear with me if you're kind of looking at this like, what is this? Okay. Our y-intercept is c. Again, that's the c from the standard form. The c is our constant coefficient or our constant. Okay, the plus c at the end. So that is always going to be the y-intercept. And if there isn't a c, if it's just an x squared and an x term, then that doesn't mean you don't have a y-intercept. That just means the y-intercept is 0. Okay, so then that means that, oh crap. There we go, okay. Almost broke everything. That means the point 0, comma C is always on the parabola. And then we have one last characteristic. If the parabola opens up, then the vertex is what we're going to call a minimum. Okay, what do we mean by that? Well, a minimum is a low point on our graph. If it's a point that is lower than everything to the left and to the right, the immediate left and right, right? And then if it opens down, it's what we call a maximum. Okay, so, you know, over here on the left hand side parabola, this is a minimum. Okay, and the coordinates are negative b over 2a, comma, f of negative b over 2a. And then same idea with the other one. This is a maximum. With the coordinates negative b over 2a, comma, f of negative b over 2a. I'm running out of room. There we go, okay. And then we have our axis of symmetry, which cuts through the middle of the parabola and it cuts through the vertex. The equation, and that's what this is right here, that's the equation of the axis of symmetry. It's a line, so remember, we have equations for lines. And it matches up with the fact that when we have x equals a number, we have a vertical line. Okay, same thing over here. Our axis of symmetry crosses through the vertex, and it's x equals negative b over 2a. And then lastly, we have our y-intercept, 0, comma c, 0, comma c. Okay, so those are the properties, the general properties of our quadratic functions. Let's go ahead and, you know, see these in action, since some of them might be a little confusing right now. Okay, so for this first one, we're going to graph the quadratic function. We're going to label the vertex and axis of symmetry, and we're going to identify whether the vertex is a maximum or a minimum. Okay, so we're going to do this without a table, and we're going to use all the properties that we've talked about above. So the first thing we want to do is let's go ahead and find out where the vertex of this thing is. Okay, so the vertex, remember, I get the x value by doing negative b over 2a. Well, remember, this is a, this is b, and this is c. Now here, there is no coefficient, so it's implied that it's a 1. So our a is 1. Our b is negative 2, and our c is negative 1. Let's go ahead and write that down just so we're clear. A is 1, b is negative 2, and c is negative 1. Okay, if we do this, we have negative 2 divided by 2 times 1. Negative 2, that's going to be positive 2 divided by positive 2, which is 1. So that's the x value of our vertex. If I want the y value, I need to do f of negative b over 2a. But negative b over 2a, instead of writing that monstrosity, I know in this case it's 1. So f of 1. I'm plugging in 1 into my function, so I substitute 1 for each of my x's. 1 squared minus 2 times 1 minus 1. 1 squared is 1, minus 2 minus 1. 1 minus 2 is negative 1, minus 1 equals negative 2. So my vertex is 1, comma, negative 2. Okay, so we can plot that right now. 1, negative 2 is my vertex. Now we know one other point. We know our y-intercept, okay? So the first thing you should do is find the vertex whenever you're graphing your quadratic functions. That's the first thing you should do. Find the vertex. The second thing you should do is find the y-intercept, okay? And our y-intercept is our c value, and our c value is -1. So we know another point, 0, -1. Okay, and maybe the next thing we should do is draw our axis of symmetry. And we already know the axis of symmetry because remember, it's the x-coordinate of our vertex. It's this thing right here, which is 1. So our x equals to 1 is our axis of symmetry. So we know that our parabola is going to be cut in half by this line. And we can use that to our advantage because we know that it's mirror images, right? So if this point is here, then it should be exactly the same distance across as another point over here with the same y value. So if I'm 1 away from the axis of symmetry, then there's another point on this side of the axis of symmetry that's 1 away from that y-intercept. So that gives us a free point. Okay, so now the very last thing we need to do is we get to just pick another point to figure out. We usually call this thing a test point. Okay, so the first thing we should find is a test point. And that just means pick any x value to plug into the function that you haven't figured out yet. We figured out 0, 1, and 2. So we can either pick -1 or 3. 3 is going to probably give us some big numbers. So let's pick -1. So f of -1 is equal to -1. Oh, excuse me. Oh, no, that was right. I don't know why I thought that was wrong. -1 squared minus 2 times -1 minus 1. -1 squared, that's 1. -2 times -1, that's +2 minus 1. 1 plus 2 is 3. Minus 1 is 2. So at -1, I have a y value of 2. And now I get to reflect it directly across. This one is 1, 2 away. So then the other side, it should be 1, 2 away at the same y value. Okay, and now we get to make our beautiful parabola. Again, yours will probably be more beautiful. Every time I think it's about to not look too bad, I mess it up on the left-hand side. Okay, so there it is. Last thing we have to do is determine whether the vertex is a maximum or a minimum. What do you think here? What is it? Well, in this case, since it's the lowest, it's going to be a minimum.